In this video, we're going to go over some practice problems from sections 8.2 through 8.5 from our textbook. So we're going to start with section 8.2 here. We're going to look at some questions where we want to use the quadratic formula to solve each equation. And so the quadratic formula is written here, and this applies for a quadratic equation written in standard form, which is what we have here on the right-hand side, where a, b, and c are the coefficients of our squared, linear, and constant term. So let's look at question 8 here. We're going to use the quadratic formula to solve this guy. So in this case, our a is going to be 8, our b is 10, and our c is -3. So let's plug this information into our quadratic formula. So x is going to be equal to opposite of b, so -10, plus or minus the square root of b squared, so 10 squared, minus 4 times a times c. This is all under our square root, and then this whole thing is all over 2 times a. So from here we can simplify this. So we're going to have -10 on the outside, and then under our square root we're going to have 100 plus 96. So this will give us the square root of 196, and this is all over 16. So from here, we know that the square root of 196 is going to give us 14, so we're going to have -10 plus or minus 14 in our numerator, all over 16. Now reducing this fraction here, this is the same thing as -5 plus or minus 7 over 3, and over 8. And from here, we can actually figure out what these values are. So we have -5 plus 7 over 8 is going to be one of our solutions. This is going to be positive 1 over 4. And then our other solution is going to be -5 minus 7 over 8. This will give us a -3 over 2. So in this case, our solution set is then going to be x is equal to -3 over 2 and positive 1 over 4. So this brings us to question 22 here, and again what we want to do is use the quadratic formula to solve this equation, but the first thing to note is that this guy is not in our standard form, this guy here. So what we're going to have to do is rewrite this so that it is in standard form. So the first thing we'll do is move this 3r squared term to the other side of our equation. We're going to be left with minus 3r squared plus 26r minus 2 gives us 0. So from here, we can now use our quadratic formula here. R is going to be equal to opposite of our b, so that would be minus 26 plus or minus, we're going to have b squared, so 26 squared minus 4 times a times c, and this is all over 2 times a. Alright, so let's see what we have. We're still going to have this minus 26 and this plus or minus on the outside. Then under our radical, if we take the square of this and then subtract out this guy here, we're going to get the square root of 652. And then in our denominator, we're going to have a -6. So the next thing we'll do is try to see if we can simplify this a little bit further. We can definitely simplify this radical here. Using our product rule for radicals, we can break this up into 2 factors. This is going to be the same thing as the square root of 4 times the square root of 163. And this is still all over -6. So we know that the square root of 4 gives us 2. So we're going to have plus or minus 2 times the square root of 163 over -6. So now we can simplify this here. All 3 of these terms share a factor of 2. So if we take that factor out, we're going to be left with minus 13 plus or minus the square root of 163 all over a -3 here. Now notice that we have a negative in our numerator and denominator here. So what we can do, and we also have this plus or minus here. So what we can do is take a negative out of all of these guys. What we're going to be left with then is what's in our solution set, so I'll just write that here. That's going to be positive 13 plus or minus the square root of 163 all over positive 3. So this would be our solution set here. Since we're not going to get nice numbers when we evaluate this, we can just leave this as our answer. All right, so this brings us to question 41 here. Let me actually move this so we have enough room. So for question 41, again, we want to use the quadratic formula to solve this guy, but we're going to have to do a little bit more rewriting. The first thing that we'll do is we'll distribute this x here to both terms inside of our parentheses. So we're going to have 3x squared plus 4x, and in the same move, what I'll do here is I'll also add 2 to both sides of our equation, just so we have 0 on the right-hand side, so that our guy's in standard form. So adding 2 to both sides of our equation, we're going to end up with this here. So let's use our quadratic formula. We're going to plug in our information. We're going to have opposite b, so minus 4, plus or minus b squared minus 4 times a times c, all over 2 times a. So from here, we're going to get, under our radical here, we're going to have the square root of negative 8 divided by 6. So notice we have the square root of a negative number, so we're going to have to rewrite this with a positive under our radical, and we can do that using our imaginary numbers. So this is going to be the same thing as plus or minus I times square root of 8 all over 6. Now what we can also do is simplify this radical here. We have the square root of 8. We know, let's do it on this side here. Using our product rule, this is going to be the same thing as the square root of 4 times the square root of 2. And we know that the square root of 4 gives us 2. So square root of 8 is going to reduce to 2 root 2. So we're going to have negative 4 plus or minus 2i times root 2 all over 6. Now from here, all of these terms share a factor of 2. So taking that out, we're going to be left with minus 2 plus or minus I times root 2 in the numerator, and then 3 in our denominator. So our solution set then is going to be exactly that. We're going to have negative 2 plus or minus I times root 2 all over 3. Alright, so this brings us to section 8.3. Now in this section, what we're going to be doing is solving equations that lead to using quadratic methods. So for this example here, question 18, we want to solve this rational equation. We know from previous sections, to do that, what we're going to do is multiply both sides of this equation by the least common denominator. So the LCD of this guy, I'm going to write this over here so we have plenty of room. The LCD of this guy is going to be the product of these two denominators here. So this would be 6x times x plus 1. And you could multiply this right away, but I am going to leave it in this factored form here so we can easily see what's going to cancel when we multiply by the LCD. So doing this on both sides here, let's see what we get. So for this guy, this first term on the left-hand side, we're going to have 4 times this. So let's write that over here. We're going to have 4 times 6x times x plus 1 all over 3x. Now for the second term here, we're going to have minus this guy times 1. So this will just be 6x times x plus 1 all over 2 times x plus 1 here. And then on the right-hand side, we're just going to have our LCD. So from here, let's see what can cancel. Notice for this first term here, we have a 6x and a 3x. So these guys are going to cancel. We're just going to be left with 2 here. Now for the second guy here, this x plus 1 is going to cancel on the top and bottom. And then we also have a 6 and a 2 here, so we're going to be left with just 3x there. And then nothing's going to cancel on the right-hand side. So let's see what we have here. We have 4 times 2 times this. So we're going to have 8 times x plus 1. And then we just have a minus 3x here. And on the right-hand side, what I'm going to go ahead and do is just distribute the 6x to both terms here. So we're going to have 6x squared plus 6x on the right-hand side. Now from here, what we're going to want to do is try to combine like terms and see if we can get a quadratic equation in standard form. So I'm actually just going to move this guy and this guy to the right-hand side of our equation here by subtracting this from both sides and then adding 3x to both sides. Doing that, we're going to have 6x squared plus 6x. We're going to have minus 8 times this, so what I'm going to do is just distribute this negative 8 to both terms here. So we're going to have minus 8x minus 8, and then we have plus 3x. And this is all going to be equal to 0 since we moved everything over to the other side. Now from here we can combine like terms. We have 3 terms that have x's here, and then we just have this minus 8. So we're going to end up with, we're going to have 6x squared plus x minus 8, and that's going to be equal to 0. Now we have a quadratic form, or a quadratic equation in standard form, so we can use our quadratic formula to solve. We're going to have x is going to be equal to opposite b, so negative 1, plus or minus b squared, so 1 minus 4 times a times c. This is going to be all over 2 times a, so that gives us 12. Alright, so this means x is going to be equal to negative 1 plus or minus the square root of 193 all over 12. And we can't simplify this any further, so this is going to be our solutions here. Alright, let's look at question 40. We're going to do something similar, but notice we have the square root on the right-hand side of this equation. Well, we've seen from previous sections that if we want to solve an equation of this form, we're going to want to get rid of this square root. And to do that, we're going to square both sides of our equation. So doing so, we're going to end up with z squared on the left-hand side, and then just whatever is under the radical on our right-hand side. So now let's try to write this in standard form here so we can use our quadratic formula. What we'll do then is subtract 5z on both sides and then add 4 to both sides of our equation. So we're going to have z squared minus 5z plus 4 is equal to 0. Now we can use our quadratic formula to solve. So we're going to have z is going to be equal to opposite b, so that's actually going to be positive 5, plus or minus b squared, so that'll be 25 minus 4 times a times c. And this is going to be all under 2 times a, so just 2 here. Alright, so let's see what we get here. We're going to have 5 plus or minus. We're going to have 25 minus 16, so this will be the square root of 9 over 2. This is going to give us 5 plus or minus 3 over 2. So this means we can do this on the side here. We're going to have 5 plus 3 over 2, which is going to give us 8 over 2, which gives us 4, or 5 minus 3 over 2, which gives us 2 over 2, which gives us 1. So that means our solution set is going to be 1 and 4 for this one. Alright, so this brings us to our next question here. We're going to be solving a motion problem. And we've seen problems like this before. What we're going to do is utilize the fact that distance is equal to rate times time. So this means time is equal to distance divided by our rate. So we're told that a pilot flew for 6 hours, so this is going to be our given time. She traveled 810 miles with the wind, then turned around and traveled 720 miles against the wind. The wind speed was constant of 15 miles per hour, and what we want to do is find the rate of the plane. So let's assign this unknown value, the rate of the plane, to a variable. We're going to call it r. So this means with our given information, we can write down several pieces of information. First being that she traveled 810 miles with the wind. So if she's traveling with the wind, let's write this down. The rate with the wind is going to be the rate of the plane plus the wind speed. So this will be r plus 15 miles per hour. And then if we're traveling against the wind, so rate against, this is going to be the rate of the plane minus the wind speed. Alright, so we have those two pieces of information. And so We're also told that the pilot flew for a total of 6 hours. So this means when she traveled this many miles with the wind and then turned around and traveled this many miles against the wind, that total time flying was 6 hours. So the first time we're going to call T1 when she's traveling with the wind, using this formula that time is equal to distance over our rate here. We know that she traveled 810 miles with the wind, so that'll be 810 divided by r plus 15. And then for the second time period, when the pilot turned around, she traveled 720 miles against the wind. So again, using this formula, that'll be 720 divided by r minus 15. Now, like I said, the total time traveling was 6 hours. So this actually means that the first time period where she was traveling with the wind plus the second time period against the wind must be equal to 6 hours. So with this information, we can construct an equation. So let's do that up here. If the first time period plus the second time period is equal to 6 hours, that means this whole guy plus this one is going to be equal to 6 hours. So we're going to have this here is equal to 6. Now, this just becomes a rational equation, and we know exactly how to solve this guy. The first thing that we need to do is find the least common denominator, and that's going to be the product of these two denominators here. So the LCD is going to be this here, and so we're going to multiply both sides of our equation by this LCD. All right, so doing that, let's color code some stuff. Multiplying the LCD by this first term here, since we have a r plus 15 in the denominator, it's going to cancel with this term of our LCD. So these guys are going to cancel. And then by the same logic here, when we multiply this LCD by this second term, since we have an r minus 15 in our denominator, it's going to cancel with this term of our LCD. So just a color code to show what's canceling with what here. All right, so this means when we multiply the LCD by this guy, we're just going to be left with this numerator times the term that's left over. So this will be 810 times r minus 15. And similarly for this guy, when we multiply by the LCD, since these guys are going to cancel, it's going to be the numerator times this r plus 15, the remaining term. All right, now on the right-hand side, we're just going to have 6 times the product of these guys. We'll notice that this is going to be a difference of squares here. So this is just going to be r squared minus 225. All right, so from here, let's see if we can simplify this further. Let's distribute this 810 to both terms here and this 720 to both terms here. Doing that, we're going to get 810r minus this guy plus our 720r plus 720 times 15, which is this guy here. All right, and then on the right-hand side, we'll distribute this 6 to both terms here. We're going to get 6r squared minus 1350. All right, so now what we can do is combine like terms. We have an r term here and an r term here, and then we have our two constant terms here. So combining these, let's see, we're going to get this for our r term. Our constant term is going to be, we have this minus 1350 here, and then on the right hand side we still have this. All right, so now let's try to move everything to get everything on one side of our equation. So what we'll do here is we'll add this 1350 to both sides of our equation. Now notice when we do that we're actually gonna, these guys are gonna completely cancel. We have this minus 1350 on both sides. Next, we'll subtract this 1530r to both sides of our equation. And let's see, almost running out of room, but on the left-hand side here, this is just gonna be 0, and on the right-hand side, we're gonna have 6r squared minus 1530r, and like I said, that's going to be equal to 0. So from here, we can factor this guy. We can pull out a 6 from both of these terms. We're going to get r squared minus 225r. Actually, what we'll do, we want to pull out the greatest common factor, so we'll pull out a 6r from both of these guys. We're going to be left with r minus 225, and this is all equal to 0. Now from here, we can use our zero factor property to solve this. If this is going to be equal to 0, then either this must be equal to 0 or this must be equal to 0. So we're going to have 6r is equal to 0, or r minus 225 is equal to 0. So this tells us r is equal to 0 or r is equal to 225. All right, now if we go back to this problem, we're trying to find the rate of the plane. So we're saying the rate of the plane is either going to be 0 miles per hour or 225 miles per hour. And in the context of this problem, we know that the plane is not traveling at 0 miles per hour. So our final answer here is going to be 225 miles per hour is going to be the rate of the plane. All right, so for the last question in this section, we're going to be solving an equation that looks like this here. And to do that, we're going to be using substitution and our exponent rules. We're going to be using this rule here that says a to the power of m times n is the same thing as a to the power m, and this whole thing being raised to the power n. So we're going to use this to rewrite this guy here. Notice we have x to the 2/3 power. Well, this is going to be the same thing as x to the 1/3 power squared. And then we also have just x to the 1/3 minus 2 is equal to 0. Now the reason why I'm leaving this second term, this x to the 1/3 as is because notice we have two x to the 1/3 terms now. So what we can do then is use substitution. If I introduce another variable, let's call it u, as being x to the 1/3 power, what I can do is substitute this u directly into this equation here whenever I have x to the 1/3. So I will end up with u squared plus u minus 2 gives me 0. So by doing this here, we rewrote this kind of complicated equation here into something much simpler. Now what we'll do here is factor and then use our zero factor property to solve this guy. Well, we can factor this quadratic equation. This is going to be u plus 2 times u minus 1. Using our zero factor property, this means u is going to be equal to negative 2, and then u is going to be equal to positive 1. But we have to be careful, this is not our final answer, because we said u is equal to this. So what this means then, if u is equal to negative 2, this means x to the 1/3 power is equal to negative 2. And then if u is equal to 1, this means x to the 1/3 power is equal to 1. So from here, we can solve this. X to the 1/3 is the same thing as the third root of x. And we know that we can get x completely alone by then squaring both sides of our equation here to get rid of this third root. Doing that, we're going to have x by itself, and we're going to have a negative 2 cubed, which we know is going to give us a negative 8. And doing the same thing for this other guy here, we're going to cube both sides of our equation to get x completely alone. We're going to get that x is equal to 1. So our solution set for this guy is going to be negative 8, 1. All right, so this brings us to section 8.4. The first thing that we're going to do is solve this equation for this variable r. So in order to do that, we need to completely isolate this variable r. The first thing that I like to do is to make sure that we get rid of all of our fractions. And we can do that by multiplying by 3 on both sides of our equation, and then we're going to get rid of this 1/3 here. So our equation becomes 3v is equal to pi r squared times h. Now from here, since we have r squared is being multiplied by pi and h, we can just divide both sides by that. We're left with 3v over pi times h is equal to r squared. Now again, we want r to be completely alone here, so what we're going to do is take the square root of both sides. Doing so, we're going to have r is going to be equal to, and we can't forget the plus or minus. When we take the square root of this variable here, our possible solutions are going to include the positive and negative version of this square root here. So we're going to have plus or minus the square root of 3v over pi times h, and this is going to be the same thing as plus or minus the square root of 3v over the square root of pi times h. Now this actually is not going to be our final answer because this is not a fully simplified version. We have this square root in our denominator, so what we're going to want to do is rationalize this denominator. We can do that by multiplying both sides multiplying the numerator and the denominator by the square root of pi times h. Doing that, we're going to get plus or minus the square root of 3v times the square root of pi h all over, if you take the square root of pi h and multiply it by the square root of pi h, these radicals are actually going to cancel out, so we're just left with pi h in the denominator. So that's how we're rationalizing the denominator. And then lastly, using our product rule here, since these guys have the same square root, we're taking the square root of both of these, we can multiply them under our square root. So we're going to have the square root of 3v pi h all over pi h. And so this would be our final fully simplified answer. For this next question here, we're going to be using our Pythagorean theorem to solve it. So we're told that a 13-foot ladder is leaning against a house. And I have that diagram here. This is the house, this is the ladder. And we're told that it is 13 feet in length. Alright, so the distance from the bottom of the ladder to the house, so this here, is going to be 7 feet less than the distance from the top of the ladder to the ground. What we want to do is figure out this distance here, how far the bottom of the ladder is from the house. So first, let's assign some variables to things. Let's call the distance from the top of the ladder to the ground the height, so this will be h here. And then this means that if the distance from the bottom of the ladder to the house is 7 feet less than h, this can be written as h minus 7. So that means this distance here is h minus 7. What we want to do then is find the height of this guy and then use that to find this distance here. Alright, so we can do that using our Pythagorean theorem. This says that a squared plus b squared is equal to c squared, or in other words, one leg squared plus the other leg squared is equal to the square of our hypotenuse here, the longer side. Alright, so what we're going to do is plug in these legs here. So a is going to be h here, so that'll be h squared. Then our b is going to be this leg, so this will be h minus 7 squared. And this is equal to 13 squared on the right-hand side. Alright, so this gives us h squared still there, and then evaluating this, we're going to get h squared minus 14h plus 49, and then on the right-hand side, we're going to get 169. Alright, so now what we'll do is, let's move this 169 over to the other side, and then combine like terms. Notice we have an h squared and an h squared here. So doing that, we're going to get 2h squared minus 14h, and then we're going to take 49 minus 169, so this will give us a negative 120, and this will all be equal to 0. Alright, so now we have a quadratic equation in standard form. We can try to factor this guy. Notice that all three of these terms share a common factor of 2. So if I pull that out, I'm going to be left with this here, and this guy is going to become much easier to factor. Factoring this, we need two numbers that are going to multiply to be minus 60 and add to be negative 7. So this would be this would be negative 12 and positive 5. Alright, now using our zero factor property, let's move this over here. This means that if this whole thing is equal to 0, then either this guy or this guy is going to be equal to 0. So this tells us that h is going to be equal to positive 12, or h is going to be equal to negative 5. All right, but remember, in the context of this problem here, we're trying to find the height of this guy and then the distance here. So it wouldn't make sense for us to have a negative height. So this is going to not be a solution here. We can't have negative height. All right, so from here, we know that the height must be 12 feet. And the question was, how far is the bottom of the ladder from the house? So this distance. So what we can do then is plug that 12 into our equation here for this distance. So this will be 12 minus 7, which gives us 5. So that means the distance between the bottom of the ladder and the house here is going to be 5 feet. Alright, so this brings us to our next question here. We're told that a rectangle has a length of 12 meters less than twice the width. And before we move forward, I'm just going to draw that so we have a good idea of what this looks like. Yep. It's going to be a rectangle. Alright, so we're told that the length of this is going to be 2 meters less than twice the width. Well, the width is going to be this guy, and so the length here is going to be 2 meters less than twice the width. So that looks like that there. All right. Now we're told that if we add 5 meters to the width, the resulting figure is now going to be a square with an area of this. So if we add 5 meters to the width, we now actually have a square. So that means the length and the widths are equal. So we're adding 5 meters to the width here. And since we're dealing with the square, like I said, these guys are going to have equal length and width. So we're going to have w plus 5 for the length as well. We're also told that the area is 144 meters squared. So we know that the area is going to be length times width, or in this case, our width squared. Since we have a square, the length and widths are equal. So what we can do is plug in our given information. The area is going to be 144 meters squared, and this is going to be equal to the width of our square squared. So this would be w plus 5 squared. Okay? Just to emphasize, if we wanted to find the area of this guy, it would be w plus 5 times w plus 5, which is this guy squared. All right, so now let's try to see if we can solve for w. We're going to take the square root of both sides of our equation to get rid of the square. The square root of 144 is going to give us 12, and so we're left with 12 is equal to w plus 5. Now subtracting 5 from both sides, we're going to get that the width of this guy is going to be 7, and that'll be 7 meters. Alright, now we want to find the dimensions of the original rectangle here. So we're going to need to find the length of this guy. Well, since we have our width, we can just plug this directly into our equation here. So length is going to be 2 times our width, which is 2 times 7, minus 2. So this will give us 12 meters. So the dimensions of our original rectangle are 7 by 12. Alright, so this brings us to our last example for section 8.4. We're told that an object is projected directly upward from the ground. After t seconds, its distance in feet above the ground is going to be given by this equation here. So with this information, we want to figure out after how many seconds will the object be 128 feet above the ground. So 128 feet is going to be our output, or s of t here. So what we can do is just plug that directly into our equation. We're going to get this here, and then what we want to do is solve for t. So we have a quadratic equation. So again, the first step is going to be to write this in standard form. So we'll move the 128 to the other side of our equation. We're going to be left with this here, and this is going to be equal to 0. So the first thing that we'll do is pull out a greatest common factor. All of these guys share a factor of negative 16. So we're going to pull out the negative. We're going to be left with t squared minus 9t plus 8, and this will be equal to 0. So now this guy becomes much easier to factor. We're going to have this negative 16 on the outside, and then we're going to have t minus 8 times t minus 1. So using our zero factor property then, this tells us that t is going to be equal to 8 and t is going to be equal to 1. And remember, we're trying to figure out after how many seconds the object will be this high above the ground. And we have two solutions here. And this actually makes sense after 8 and 1 second, because this object is being projected directly upward from the ground. So if we were to think of this, the ground is here, and if we project this guy, and this is 128 feet. So if we were to project this guy from right around here, what's going to happen is that it's going to have to come back down to the ground. So it would be hitting this height of 128 feet at two separate points. So this would happen at 1 second and then again at 8 seconds. Alright, so this brings us to section 8.5, and in this section we're going to be solving quadratic inequalities. And the idea here is to first write the given inequality as an equation and solve it, and those solutions are going to determine intervals on our number line. And as we're doing this problem, it'll kind of become clear while we're doing this, but like I said, the first thing that we're going to do is write this as an equation and solve it. So what we're going to do is subtract 8 on both sides of this guy so that we have a quadratic equation in standard form. Now if I move this minus 8 over, I'm going to be left with 0 on the right hand side, but like I said, we're going to write this as an equation, not an inequality, so this is going to be equal to 0. We're not going to have greater than or equal. Alright, so from here we want to solve this guy. So we're going to use our factoring methods that we've seen in the last several sections. Since we don't have a 1 here for our square term, this is going to be a little bit harder to factor, but we can use the method where we're going to be factoring by grouping. So what that means is we want to multiply the coefficients for our a and c here. We're going to get 3 times negative 8, which gives us a negative 24. So with this, the goal is to find two numbers that multiply to negative 24 and add to our b term, which in this case is positive 10. So those two numbers then are going to be negative 2 and 12. So from here, what we're going to do with these two numbers is break up this middle term into two different terms and then factor this by grouping. So we have our 3x squared plus 10x minus 8, and this is going to be equal to 0. So like I said, we're going to break up this middle term using these guys. We're going to rewrite this middle term as minus 2x plus 12x. So that way, now that we have 4 terms, we can factor this by grouping. And so we're actually going to group it just exactly how it is here. And we can do that because these guys share a common factor of x and these guys share a common factor of 4. So we're going to do exactly that. We're going to pull out this common factor. So we're left with 3x minus 2. And then for this one, we're pulling out the common factor of 4. So we're also left with 3x minus 2. So finally, pulling out this common factor of 3x minus 2, we're left with x plus 4. So this is this equation here factored. So from here, we want to solve this. We're going to use our zero factor property. So this means 3x minus 2 is going to be set equal to 0. So x must be equal to positive 2/3. And doing the same thing for this guy, x must be equal to negative 4. So like I said, these solutions here determine intervals on our number line. So what we'll do is graph that. We have this number, negative 4 and 2/3. So what's happening here is that the real number line is being broken up into 3 different intervals. I'm going to call this interval A, it's all of the numbers less than negative 4. This one would be interval B, all of the numbers in between our two solutions, our two roots here. And then the last one is interval C, everything greater than this solution, this 2/3. Now, if you go back to our original inequality here, after moving this minus 8 over, this is going to be the same thing as 3x squared plus 10x minus 8 is going to be greater than or equal to 0. So essentially what we're trying to do is find x values that make this statement true. Now by setting this equation equal to 0 and solving, we found two values that make this guy exactly equal to 0. And so that's why our number line is split up into these intervals. At these exact points, we know that this equation is exactly equal to 0. Now everywhere else, these three intervals, what we want to do is determine the sign of these intervals, because that'll tell us if this guy is going to be greater than 0. So in order to do that, what we're going to do is pick what's called test numbers from each interval here. So let's do a test number in interval A. So any number that's going to be less than -4, so we'll say -5 in this case. So if we let x be equal to -5, what we're going to do is plug -5 into our equation here. And actually, to make our lives a little bit easier, we could actually plug it into our fully factored form as well. So plugging it into our fully factored form, we'd plug a -5 into here, so this would give us -17, and then plugging a -5 into here gives us a -1. So this guy is equal to +17, which we know is definitely greater than or equal to 0. So that means everything in this interval here, all of these x values will satisfy this guy. Let's do the same thing for interval B. Let's pick a number in that interval. We can pick x is equal to 0. Plugging in 0 into these guys here, we're going to get -2 times +4. So this is going to be a negative number. This is -8, so we know that this is definitely not going to be greater than or equal to 0. So this means actually that everything in this interval is not going to satisfy this. We're always going to end up with a product of this form of a negative times a positive, which will always give us a negative. In the previous interval, we're always going to end up with a product of this form, a negative times a negative, which gives us a positive. And all positive numbers are going to satisfy this, greater than or equal to 0. All right, let's test the last interval then. Picking a number in this interval, let's pick an easy one. Let's let x be equal to 1. Plugging that in to our factored form of our quadratic equation, we're going to get 5, which is definitely greater than or equal to 0. So that means everything in interval A and C is going to satisfy this inequality here, but nothing in B will. So our final answer, which we'll write in interval notation, is going to be everything in interval A, so everything less than -4, which is -infinity up to -4. And what we're going to do is use brackets here to include this value of -4. Remember, -4 is a solution to this guy when our equation is exactly equal to 0. And if we go back to our original inequality here, we are looking for x values that will make this greater than or equal to 0. So -4 making this equal to 0 means that this is going to be included in our solution set. By the same reasoning, this 2/3 is also going to be included in our solution set, so we're going to use brackets, and this is going to go all the way up to positive infinity. So all of our solutions are going to lie in these intervals here. All right, so for this next example, we want to figure out what x values will make this statement true. And before we do the process that we saw in the last example, we kind of want to think about what this question is asking. We're saying, are there any x values that will make this whole thing squared less than 0? And the answer to this is no. If something's going to be less than 0, then it's going to be a negative value. This guy here, this 2x plus 5 squared, is never going to be a negative value. So we'll say never be negative, since anything, no matter what this x value is, squared is going to be a positive value. So no x value will ever make this guy less than 0. So for this one, we would say that the solution set is the empty set. All right, so that was a special case of a quadratic inequality here. All right, so let's look at the next example here. Now this one's nice, it's already factored for us. So we already know that our solutions are going to be 1, 2, and 4. So in order to get to this place, if you remember from the first example, this means that these values is going to make this guy equal to 0. we're to plug 4 in for this, we're going to get 0, 2 is going to give us 0, and 1 is going to give us 0. So we want to find values that'll make this guy less than 0, not equal to 0. Now, just like we saw in the last example, or the first example, these solutions here are going to break up our number line into intervals. So we have 1, 2, and 4 here. So again, let's label our intervals, but in this case, since we have 3 solutions, we're going to have 4 intervals. Now we're just going to do the same thing that we did for the first example. We're just going to pick test numbers in these intervals and figure out what the sign of these guys are going to be. So for the first interval, I'm going to pick something there. I'm going to let x be equal to 0. So plugging that into this guy here, if x is equal to 0, we're going to have -1 times -2 times -4, which is going to be a negative number, and that will be less than 0. So that means all of the numbers in this interval here are then going to satisfy this guy, because we're always going to end up with the product of 3 negatives. So for b, let's do the same thing. So pick a number in that interval between 1 and 2, so I'll let x be equal to 1.5. Plugging that in, we're going to have 1.5 minus 1, 1.5 minus 2, and then 1.5 minus 4. Notice that this guy is going to be a positive, and this guy is going to be a negative, and this guy is going to be a negative. This means we're going to have a positive times a positive, which is a positive number. That means that statement is not true. This guy here will never be less than 0, so that means all of the numbers in our interval b are not going to satisfy our original inequality. Alright, let's repeat this process here. We're picking a number in our c interval. This will give us 2 times 1 times -1, which is going to be a negative value, so that'll be less than 0. And then for our last interval, let's let x be equal to 5. Plugging this in, we're going to get 4 times 3 times 1, which obviously is not going to be less than 0. This is always going to be positive. Everything in this region is going to give us a positive output, which is not going to be less than 0, which will not satisfy this inequality. So that means the only intervals that contain solutions that'll make this statement true is interval A and interval C. So let's write our answers in interval notation. Interval A is going to be everything less than 1, so that'll be -infinity up to 1. Now in this case, we're going to use parentheses instead of brackets because we're looking for values that'll make this whole thing less than 0, and we know that these guys are going to make this exactly equal to 0, so we're not going to include any of these values in our intervals. Alright, so our second interval then is interval C, so this will be from 2 to 4. So all of our solutions are going to lie in these intervals. Alright, so for the last question in this video, we're going to be solving a rational inequality. So this one's very similar to the previous examples. What we're going to do is set this equal to 0 and try to solve for it. So the first thing that we need to do is subtract 4 on both sides. Doing so, we're going to have this here, and then we want to set this equal to 0 and solve it. Now the only difference for this one is that we are dealing with a rational expression here. So we are going to need to figure out when this guy will be equal to 0 and when this guy will be undefined. So first what we're going to do is subtract these guys, and in order to do that we're going to need to get a common denominator. So this 4 is the same thing as 4 over 1, and so we're going to multiply the numerator and denominator of this guy by t plus 1. So we're going to have 2t minus 3 over t plus 1 minus 4 times that denominator over this common denominator. Alright, so from here, what we'll do is we'll distribute this 4 to both terms in our parentheses here. So we're going to have, and also since we have, we're subtracting both of these guys and they have a common denominator, this minus this can be all over one denominator. So we're going to distribute this minus 4 to this guy, so we're going to get minus 4t, and then this minus 4 is going to be distributed to this, so we'll have a minus 4 there, and then like I said, this is all going to be over one denominator. So let's combine like terms. So we have a 2t, a minus 4t, a minus 3, and a minus 4. So this gives us minus 2t minus 7 in the numerator, and then t plus 1 in the denominator. And like I said, we want to solve this guy, so we want to figure out when this guy will be equal to 0. The only way that's going to happen is if our numerator is equal to 0. So, because remember, 0 divided by anything is just going to give us 0. So we want to figure out when the numerator, minus 2t minus 7, is equal to 0. Now, we can just solve for t, and we'll see that this happens when t is equal to negative 7 over 2. So this is one of our solutions, and this is one of the numbers that's going to determine our intervals. The next thing we want to figure out is when the denominator is going to be equal to 0 or when this guy is going to be undefined. And we know that's going to happen when t plus 1 is equal to 0, or in other words, when t is equal to negative 1. So now these are the two numbers that are going to determine our intervals. So let's break them up here. Let's move this down a little bit. We're going to have negative 7 over 2. So that'll be right around there. And then let's say negative 1 is here. So we have our three intervals again that I'm calling A, B, and C. And so what we're going to do is what we've seen in the last several examples. Let's pick some test numbers in each interval. So in the first interval, I'm going to pick negative 4. That's a number that's going to be less than negative 7 over 2. Plugging this in to this guy here, plugging in a negative 4, I'm going to get 1 over negative 3. And so this guy is going to be less than 0. And if we go back up to our original inequality, we want to figure out what t values will make this greater than 0. Well, we have a negative, so this guy is never going to be greater than 0. This is not a true statement here, so none of our solutions are going to lie in this interval. Let's look at interval B. Let's pick a number in there, a nice number. Let's pick negative 2. Plugging this into our rational expression, we're going to get negative 3 over negative 1, which is going to be greater than 0. A negative divided by a negative gives us a positive, so that means our solutions are going to lie in this interval. All right, let's test our last interval. Picking a number in there, we'll let t be equal to 0. If we plug this into our expression, we're going to get negative 7 over 1, which is just negative 7, and we know that that guy is never going to be greater than 0. So that means none of our solutions are going to lie in the interval C either. So our only solutions are going to lie in this interval. Graphically, what that looks like is this here. And remember, we're using our parentheses in this case because we're not going to be including these solution values. If we go back to our original inequality, we want to figure out when this guy is greater than 0. We know at negative 7 over 2 it's going to be exactly equal to 0, so we're not going to include that guy. We also know that if t is equal to negative 1, then this guy is going to be undefined, and it won't be greater than 0, so we're also not going to include the value of negative 1, so we're using parentheses for these two endpoints here. And then lastly, to write our answers in interval notation, all of our solutions are going to lie in the interval from negative 7 over 2 to negative 1, and again, using our parentheses because we're not including these two values. Alright, so that'll be it for this video.